Alright, hello everyone. I'm Professor Caudill. It's supposed to be a U. Alright, so we're gonna start on 95. Okay, so police car waits in hiding slightly off the highway. So what do we know about this? What does this first sentence tell us? We can say that police car's position, let's just put it on the origin. It's waiting, so it's not moving. Okay, we don't know anything about acceleration or time yet. So this is all we know. Second sentence, a speeding car is spotted doing 40. So speed of the car is 40. At the instant the speeding car passes. Okay, so at here, the police car accelerates from rest at 4. Okay, so we're going to say A is 4. So we want to find T. So really what we're going to do is find the final X, and then we're going to plug that in. Find T. That's what I think would be correct. On this police car, take to catch the speeding car. Okay, so we've got 4 variables, we've got 3, 4, 5, so we can probably put it in equation 5. 40 for X is what we're solving for. Oh, and I messed up. 5, 40 for X, 0, 0. Okay, so it should be about 200 meters. We double check the units. Okay, 400 meters. Okay, so that's our distance. I know there's something that's like distance equals speed times time. So you could rewrite this as 200 over 40. It's 5 seconds. Don't know if that's correct. Maybe we use equation 4. I think we would use equation 4 now. So 200 for solving for t. Initial velocity is 0. Initial position is 0. Okay, so I'm getting 10 seconds. Okay, so let's check the back of the book. 95. We're getting 20 seconds. Okay, so what are we doing wrong here? They're using equation 4. We started with equation 5. It looks like they're using equation 2. Okay. So let's try with equation 2. 200 meters, 40 meters per second, solving for t. Which position is t? It's 5 seconds. Okay. X plus vt. So maybe they're using equation 3. 3, so final velocity is 40. Acceleration is 4. Time is t. Initial velocity is 0. Okay, so we're getting 10 seconds. So we found 10 seconds in 2 different equations. So I'm not sure how we're off by 10 seconds. X naught, B naught is 0. Okay, got that right. Set rest. All these, so X is 1/2 AT. 1/2 AT. So 400 over 4. Solving for t, so X over A is t. So 400 over 4. 40. Okay, so they're converting this into VT. Okay, so yeah, so that's kind of a tough problem. So let's try 96. Half a marathon. Running in a half marathon. So V naught 3. V naught is 3. Another runner, Jacob, is 50 meters behind. Another runner, Jacob's 2 meters behind Paul. Okay, so let's say his x naught of P is 0. So the velocity of J is 3. The initial position of J is x naught P minus 50. Jacob begins to accelerate at okay, so J 5 t equals okay. So this is our knowns. I feel like we should know how long half a marathon is. $21, so 1/2 marathon is 21.1 kilometers. Okay, just in case we need that. Okay. So what do we start? What do we find first? Trying to find time. So we have 2, 3, 4 are options. 0 is basically equation 3. 2, 3, 4, 2, 3, 4. Average velocity is probably hard to find here. So probably 3 or 4. Maybe we start by finding x of p. Can we do that? X of p. So that would use equation 5, I think. We don't know his final velocity though. Let's try equation 4. Displacement. Don't know that either. So probably equation 3. We need to know final velocity. They're using equation 4. So how are they getting x for equation 4? How are they finding s? Okay. So s, or x of p, is v naught times t. Okay. that's already in this. S equals UT. Yes, yeah, so these would cancel out. Okay, so it just broke. Okay. All right. Yeah. No, thank you. Uh, okay. So we want to find T. Want to find T. X naught, X, V naught, A. Okay, so we're just going to use equation 5. Solving for B, negative 0.5, 0, 8. Okay, so we're getting a complex number. So that's because we're taking a square root of a negative number. That doesn't make sense. So it's not reasonable. Let's see what the back of the book says. Book's getting a slightly different answer. All right, 98. Move on. Plane accelerates. Five meters. T is 30. X is 10. Okay. Seems to be pretty straightforward. I hope it's as easy as it looks. So we have A, X, and T. A, X, and T. A, X, A, X. A, X, T, X naught. Okay. Probably use this if X naught is 0. Okay, so let's use that. 10, 5, 30, B naught, 0. Okay, then we're going to plug that into equation 5. 5, 10, 0, 74.7. $75. Let's get a second opinion. Okay, so we missed converting kilometers. 10, 1, 2, 3. Retry. So displacement 10, 1, 2, 3, 1,000, 5, 30. V naught 258. So we went a little too fast. We messed up the units. So V5. So 408.3. 408.3. Okay. 99. Okay. Compare the distance traveled of an object. Change in velocity. So acceleration is 2v naught. Because acceleration is a change in velocity. Okay, and then we want to compare this to another object. Let's call A of 1, A of 2. So this other object is 4 times V naught. Okay, so we want to compare the distances. So let's say x naught is 0 in both cases. It's asking for displacement. So we want to compare the distance traveled. Okay, so we can use x naught as 0. We can try t is 1. And V naught is 1. Okay. So we can plug that in equation 4. Placements what we're solving for. 2 V naught. Okay, so initial velocity, position 0. Maybe retry. Placement is what we're solving for. Acceleration is 2 times 1, so it's 2. T is 1. Initial velocity is 1. Initial position is 0. So x of 1 is 2 meters. So we'll try this. 4, 1, 1, 0. X 2 is 3. Okay. Let's try t equals 2. V naught equals 2. So we'll try 4, 2, 2, 0. X 4 times 2 is 8. 2, 2, 0. 20 meters. Okay. Right, one more. So we're doing 2 times 3 for the acceleration. So it's 6. Time is 3, 3, 0. Okay. 4 times 3 is 12. 3, 3, 0. 63 meters. Okay, so if we were to graph this, okay, so we have okay, so this is 1, 2, 3. So x1, we'll do this as a dotted line. So at 1, it's 2. Sorry. At 1, x is 2. At 2, x is 12. At 3, x is 36. Okay. Now we'll do the next one. This one will be slightly more. 2 is 20. 3 is 63. This is solid. Okay, so what number is this? 99. All right, 100. Object is moving east. Constant velocity. Position X at time t equals 0. Okay, so I just don't like the English in this problem. I guess this implication is what you had to find. Oh. All right, moving on. A ball is thrown straight up. It passes a 2-meter high window. So y naught is 0. Y is 2. Okay, 7.5. This would be y naught is 7.5. 9.5. Okay. Takes 1.3 seconds to go past the window. Okay, so t naught is 0. T is 1.3. What's the ball's initial velocity? So we know x, t, a. We can say gravity. Let's say a is negative gravity. Okay, so we could find V naught with this. I think T, yeah. Let's try that. Equation 4. Displacement. We need to take the time it takes to get there. All right. 0.5, negative 9.81 times 1.3. Initial velocity is V naught, which position is 0. Okay, so let's see what the book got. 101. I'm getting 12. It's getting 7.9. Let's move on. Coin is dropped from a hot air balloon. So Y naught is 300. Okay, so coin's dropping. Source is moving up at 10 meters per second. Find the maximum height reached. Find the maximum height reached. Like this wording doesn't even make sense. It's like only one coin is being dropped. So asking the maximum height is implies you're continuously dropping coins. So yeah, I'm just getting kind of frustrated with this book. I mean, I know it's a me problem as well, uh, but I don't think all the blame's on me. I do want to try uh, like other textbooks, but I don't know if we'll have time. So tennis softball is dropped on a hard floor. Soft tennis ball is dropped. Y is 1.50. So to the ground and rebound is Y naught equals 0. So we're going to find V naught here. So we're going to find V. V naught is 0. V is what we're trying to find. Okay. So we want to find V. I'll use equation 5. Negative 9.8. Displacement is 0, 0.5. Initial velocity 0. So we're getting 5.4. Okay. So let's see what the back of the book got. 5.4. So we got the first answer right. That's good. Calculate its velocity just after it leaves the floor back up. Calculate its velocity. Wouldn't just be 5.4. They're getting a little bit less. I don't like how it's worded. Calculates like just after. Like how? What do you mean just after? Like 30 seconds after? 5 seconds after? Displacement is 0, 1.1, 1.4. Okay, so yeah, I'm going to move on. I might look at getting another textbook. To look the book in the 50s. Yeah, I wonder if I would like this more, because this textbook is just bad English. I'm sorry to say. Alright, so maybe we can just do this. A lot of text, a lot of text, a lot of text, a lot of text, a lot of text. Matter is made of atoms. Is there like problems we can solve? Doesn't seem like it. Seems like a very different approach to physics. I mean, I know these are lectures. These aren't. This isn't a textbook. Physics textbook. So Openstax, it's like the top results for me. Don't know if I want to do that. Okay. Assignments. Okay. Let's try this. Hope you guys can read that. Car is driving along a straight line with speed v naught at time t0. Car is at the origin. At a later time t, car stops slow down. So negative c minus t. This is the new equation. 1/2 acceleration minus gravity t squared. So that's kind of cool. You can take initial acceleration minus gravity. Yeah, I'm not sure if I want to continue with the physics. What is the next chapter? Dimensions in 2 or 3 dimensions. So let's review the next chapter a little bit. Looks like they're combining vectors. That vector functions. I think we could do some of this. Okay, so acceleration is the velocity function in each dimension. So that's kind of cool. Uh, projectile motion. Okay. And what after that? Okay, I mean, these look like very valuable stuff to learn. So maybe next video I'll just start here. I'm kind of getting bullied with these homework questions. I know some people believe you shouldn't move on unless you're very comfortable with homework, you know, homework questions, but we can do what we want. So, relative motion in 1 and 2 dimensions. So, yeah, we could write these out. Kind of funny because this could just be written as and you can just assume it's IJK. Um, Take this times the dot product of 1, 1, 1. Maybe you could do dot product times 1, 0, 0, 0, 1, 0, 0, 0, 1. Not sure if you could do that. And I take the dot product of a row, so 3 by 1 matrix and a 3 by 3 matrix. Pretty sure you cannot. Okay. Okay, what about maybe if we just change the order? Okay, so you can't do this, but you could do so I think you would do, yeah, I think that equals x I. So other cool equations that we have here, velocity vector. It's like we're using a bunch of different stuff here. Time of flight range. Okay, and what chapter is after this? Then we get into work and force. All right, we've got about a minute left. So yeah, I'm kind of just tired of these homework questions, how they're worded. Doesn't make my life easier. Doesn't make my life easy. So we might just send chapter 4 and tomorrow. So this will be motion 2 or 3 dimensions. So maybe this will be more intuitive since most objects follow curved paths. All right, so it'll just be expanding on chapter 3. So I think for the most part we get about half the homework questions right. So I think we're in a decent place to start on chapter 4 next video. So I will see you guys next time.